everyone. I'm Jen Weesey. I'll be your moderator for today's webinar. I work with the Grails and Micronaut team here at Object Computing, and we'd like to thank you again for joining us today. We're really excited for our presenter. He is a member of the Grails and Micronaut team here at Object Computing, Iván López, and he's joining us today from Spain. So in this complimentary webinar, Ivan's going to show us how to save some time and boost our productivity with some expert testing tips on Micronaut best practices. So with that, I will pass it over to you, Ivan.
Thank you, Jen. Hello, everyone. Thank you for joining me today in this session. Today, we're going to talk about Micronaut testing practices. I'm going to show you different approaches to test Micronaut applications, and I'm going to share with you one approach that I've been following, I've been using in a few Micronaut projects I've been working on, and that have worked really, really good. But before going into any details, let me introduce myself very quickly for those of you who don't know me. I'm Iván López, Ilomar on Twitter. I live in Madrid, in Spain, and as Jen said, I'm part of the Grails and Micronaut team at Object Computing. I spend most of my day lately working full-time on Micronaut, especially now that we are really, really close to release Micronaut 2.0. And I'm also the organizer of the Madrid Groovy user group. It's the biggest and most active Groovy user group in the world. We have a lot of talks. We record everything. They are in Spanish, so if you know Spanish or you want to improve your Spanish, I recommend you to take a look at our webpage, madridgroovy.com. And that's basically all. Let's go with the talk. So let's start with the very beginning. Why testing? So for me, testing is necessary to basically to sleep well at night. It's not to really prove that what you are doing now works. It's a safety net to be able to modify your code in the future with confidence, knowing that you are not going to break it when you modify it, right? So we can have, or we used to have this distinction of different type of tests, unit integration and end-to-end tests. And historically, we've been writing a lot of unit tests because they are fast, they are simpler, easier to write most of the time. And even if that means we need to mock a lot of parts of our code, and we are not really testing the interactions between the different components. We also write integration tests, but sometimes we decide to write, instead of an integration test, we decide to write that as a unit test because starting the whole application for running the integration test takes a lot of time. You need to wait for the application context to start up, create all the beans, etc., etc. So basically, we decide that it's not worth it to spend all that time waiting and writing integration tests. And at the end, we don't pretty much never write end-to-end functional tests because those takes forever. They are complicated to maintain. They are very, very fragile, right? So this is what happened when we only write a unit test, right? We wrote 2 unit tests, 1 per window. They were perfectly fine. We mocked the other window. But then, as we don't have an integration test, we never check that we can actually open the window, right? And there are more examples. You have the water, you have the sink, but you don't write a unit, an integration test for that. So basically the water is out of the sink. Or here, the same thing with the air dryer. You put the toilet paper on the bin, and then it's just below the air dryer and the paper goes out, right? Or my favorite unit testing your security can be something like this, right? You think that you are testing it properly, and actually you are not. And there are a lot of examples of things that we should have written integration tests, but we don't. So what about Micronaut? Basically, Micronaut eliminates this artificial separation imposed by traditional frameworks between function and unit test due to these slow startup times and memory consumptions of those frameworks. This basically means that we can run full end-to-end or integration test in just a few milliseconds. So we don't need to decide to write a unit test because we don't want to wait for the application to start up. And please don't get me wrong. I do write unit tests, but only when they make sense. When they don't, I prefer writing integration or end-to-end tests because the application starts so fast that I don't need to worry about it. In the last couple of projects I work on creating Micronaut applications, we've been writing pretty much everything as integration and unit test, and just a few, integration and functional test, and just a few unit tests. And we've talked about this, the team, and we've seen a switch between how we tested Rails applications in the past and how we now test Micronaut apps. So as I said, with Micronaut, we wanted to avoid this artificial separation of tests because they are slow to start up and they consume a lot of memory. Micronaut is a test agnostic framework, so you can choose whatever you want to test your application. We support these frameworks, Spock, JUnit 4 and 5, Spec 2, and Kotlin Test. Now with Micronaut 2, we support the ones involved, so Spock, JUnit 5, and Kotlin Test. And you don't need to worry about that, because if you create a new application using the CLI, or you generate a new app with our launch page, launch.micro.io, you can select which framework you want to use, Spock, JUnit 5 of Kotlin Test, and you will have an application ready to use any of those frameworks that you select. This is, I don't want to spend too much time on this because you will be able to generate the project on our launch page. But this is basically how it looks like your build.gradle file if you select, for example, Spock. With Maven, you can also use it. It's a little bit more verbose because of the XML, but again, you don't need to worry. The CLI or the launch page will create and put all the dependencies that you need for the testing framework you've selected. The same with the JUnit 5, different micro dependencies, JUnit Jupyter, and the same in this case, with Kotlin Test, right? So it doesn't really matter the framework you use. You can choose whatever you want. So for example, in some projects, we've also added JEP for browser testing. And again, it's just a matter of adding the right dependencies and configure it. It's all you need to do. So what I'm going to explain are 3 different approaches to test Micronaut applications. I'm going to present them, show a few examples, and explain the pros and the cons of every approach, so everyone can decide what to use and be informed about that. This is the first approach. I call it do-it-yourself manual, also called the old approach. If you saw Graham's demo at Grid 2 years ago when he introduced Micronaut to everyone here in Madrid, he explained how to, basically he did an awesome live demo, and he explained how to start an embedded server and an application context manually during the test. So this is this approach I'm talking about. And I need to explain this application context and embedded server because I'm going to talk about this for the whole talk. So I want to make sure that everyone is on the same page. When you have a Micronaut application, you have an application context. Is some kind of space in which all your Micronaut managed beans, so basically all your services, controllers, etc., live, right? And Micronaut takes care of creating those objects and do the dependency injection and everything for you. So when you have the application context, you can get one bean. Imagine that you want to get your user service, and you can call one method to test everything you want on your user service. And also you have the embedded server. The embedded server is basically the Micronaut HTTP server, which contains the application context, right? So if you want to write an end-to-end test, for example, you want to test a controller, sending an HTTP request, you need to start an embedded server for that. So we will have different approaches in case you want to start only the application context because you don't need the HTTP server, or you also need the embedded server. With this approach, you have control about everything, about how everything is created, because, as I said, you do it yourself manually, right? You need to wire everything manually, but you have control to configure and set up everything. As you do everything manually, it's a little bit verbose. That's why I call this the old approach, and we don't use this anymore. This is an example of JUnit 5. So basically, what you have is the embedded server, an HTTP client, and in your before class, you start here an embedded server, and then you create a new bean for the HTTP client pointing to that server URL, which will be localhost and some random port. Because by default, Micronaut start embedded server on a random port when you are running on the test environment. And then you also need to take care of stopping the server and the client when you finish your test. And finally, you can write your test. This is a functional end-to-end test. You are sending here, it's the basic hello world. So you have a hello endpoint here, and that hello endpoint returns just a plain string with hello world. So you use the client, the HTTP client, to send a request using the blocking HTTP client, and then you check that the body is not null, and the result is hello world, right? Pretty simple. But you see that you need to wire a lot of things up manually. Then this is the same, but with Spock. So you need to do pretty much everything. One nice thing about the Spock is that you can use this auto cleanup annotation, and what it does is automatically call the close method of the embedded server and on the client when the test finishes. So you don't need to call it manually. And then again, you write the Spock test. It's pretty much the same as I saw you with the JUnit. You do a get request to /hello, get the response, and check that the response is what you expect. So with this approach, the pros is that you have total control of everything. But the cons is, as you saw, a lot of repetitive setup, probably a lot of copy and paste and verbose between tests. With JUnit, it's a little bit of pain because you need to start the server, stop it. You can put that in some other class and insert some kind of code, but it's not that pretty, that test, right? It's a little bit ugly. It's a little bit, verbose. And you write probably more code around test than the actual test itself. So there are better options instead of using these approaches. This was good 2 years ago when we introduced Micronaut, but now we have a better approach. So let's talk a little bit about now Micronaut Test. Micronaut Test is a library that we created to make writing tests easier. It's included out of the box. So when you create, again, a new application using the CLI or the launch web page, you will have there the Micronaut Test dependency. And this library basically it provides you an extension for the testing framework you are using. So Spock, JUnit 5, and Kotlin Test. And what the annotation does is starting and stopping automatically the embedded server and the application context for you for the suite. So you don't need to worry about that. The extension, the library configures an extension, and the extension will do that for you. It also allows you to have a dependency injection in the test, just with an inject, for example. And a nice thing, it's also that it provides you this mock bean that can be used to define mock beans. So you can define a bean and replace another one for the scope of a test. We support the Spock mocks, Mockito, and Mock-K for Kotlin. If you are interested in this library, this is the documentation webpage, and it explains how to set up everything and how to configure and all you need to know. And one important, really important thing when you are using Micronaut Test is that the library does not mock any part of the framework, right? You are running the same Micronaut application and the same real one that you will run on production. There are no mocks created for you just because you added this application, this library on your class path for the test. You will run always your same application, and this is really important because with other frameworks, it's not the case. When you start the framework in the test environment, there are maybe some mocks for some parts of the framework. Here, you won't have any mock. Another nice thing about this library is that you have this test property provider. It's an interface that you can implement in your tests, and it allows you to define new configuration properties that you need for the test. So for example, imagine that you have this book controller test, you annotate it with Micronaut Test, you implement the interface, and you need to override this method, get properties. And here you return a map, and this foo bar is a configuration key, and this is the value, ABCD, right? It's the same as if you put this configuration on your application YAML, on your application test YAML. But this will only be valid for this test. If you need to configure something and you want to test that, this is the approach you can use. Another approach is also annotating your class or your method with a property, and it's the same. You define the key you want to use for your configuration and the value, and in that class, in that test class, or in that test method, Micronaut Test will start the application context and the embedded server with this, or with, in this case, with this one, with this property defined with this value. So you can get that property and do whatever you want or whatever you need. So with Micronaut Test, this is the previous test I showed you before with this all do it yourself manually. So basically with Micronaut Test, we can get rid of this. We don't need it anymore. And now our test is it's something like this. We annotate our class with a Micronaut Test. We can inject our dependency, our HTTP client, and we can write the test the same thing as we did before. I want to open here some kind of small parentheses and a warning about using inject. So Micronaut supports dependency injection by constructor, field, and setter. And we always recommend you to use constructor injection because it allows you to define your dependencies as final. So once the bin is created with all the dependencies, they can't be changed. Never, because they are final and there is no way to modify them. We don't recommend you to use at inject or setter injection because because basically you don't have that feature of not being able to modify your dependencies. So in this case, for a test, it's fine to use at inject, but please don't do this on production code. Always try to use constructor injection. And now for Spock, pretty much the same. This is the old test. We can get rid of this. And now we have the new version of our test using Micronaut Test. Annotate the class, inject again our HTTP client, in this case the reactive one, and then we can test it. As we are using the reactive HTTP client, we call this to blocking method here, basically because we don't want to deal with in the test. It's easier just to block the request and get the response from the server instead of using the asynchronous HTTP client in which you need to basically manually subscribe to the result or to the future or whatever you are using under the hood, right? So for a test, it's better just block and then get the request, unless you are testing something specifically about asynchronous. Then you won't use this to block. But in most of the cases for testing, we always do this to blocking. So what are the pros of this approach? Micronaut Test automatically will start the embedded server and the application context for you. You don't need to worry about that. You have automatic bin injection with inject annotation. You have mock bin to mock different dependencies or different bins. You can define configuration properties with implementing this test property provider interface or annotating your class with that property. On the con side, as everything is automatic, you have less control, right? And that means also that you need to put Micronaut tests everywhere. You need to annotate all your tests with Micronaut Test to trigger the execution of that extension for the framework, the testing framework you are using. And as you annotate your classes with Micronaut Test, it means that the library will always start an embedded server and application context for you, even when it's not necessary. So for example, if you are testing, I don't know, a repository and you want to save something, for example, on the database and check that it's safe and you can retrieve it, you don't need to start an embedded server for that. You only need the application context to get the user repository bin, for example, call the save method, call the find users method, and check all the results, right? So if you use this approach for that test, even if you are not using the embedded server, even if you are not sending an HTTP request, you will have an embedded server running. It doesn't really matter because everything starts so fast that you won't notice the difference, right? But maybe there is a better way or another approach that we can follow. And I call this approach do-it-yourself on steroids, like plus plus, right? This is the last approach I'm going to show you. I'm going to spend the rest of the talk talking about it. And as I said, I've been using this approach in the last 2 projects I work on, developing Micronaut applications. It has worked really, really good. One of those projects was really big with a lot of microservices and modules. And this approach has been tested and it's flexible enough to modify when we need to evolve something and easy to maintain. So first thing first, and please don't disconnect from the webinar now. We do love Spock. So for me, it's the best testing framework in the JVM ecosystem. Even with all the new features in JUnit 5, I don't think it can beat it. It can beat Spock. Spock tests are really, really beautiful, are simple to read and to maintain, and using Groovy for test, it's so, so powerful. And I don't really know why folks don't want to try, right? They prefer to still write in verbose the unit test. But anyway, so in this approach I'm going to show you, it's based on Spock, but as I said, please do not disconnect now. You will be able to adapt what I'm going to show you to JUnit and Kotlin if you prefer to use those frameworks for testing. Probably it won't be that pretty, but it will work, right? And even if you don't want to adapt that, I think you will learn some tricks today. So we are going to use parent abstract classes to basically extend from those classes. Instead of extending directly from a Spock specification, we will extend from these classes and we will put some utility methods there. We are going to use Groovy traits. For those of you that don't know Groovy or traits, traits are awesome. They were introduced in Groovy probably 6 or 7 years ago. And basically, they allows us to compose behavior and apply that behavior where we need. What we usually do is that when we want to share code, we create some kind of artificial hierarchy of classes that probably they don't it doesn't make sense to have that hierarchy of classes, but we put there because we want to share some code, right? So we put a parent class and we put there a lot of code that they are not related, but it's one way we have to share code. So with traits, you will have this pluggable behavior and you will apply the traits when you need. You can have something similar with the default methods introduced for interfaces introduced in Java 8. They are not exactly the same, but it will work. We are also going to take advantage of the Groovy setters behavior. So if you have a Groovy class called user and you have name and last name, in Java you will do user.getName, user.getLastName. In Groovy, you can do user.name, user.lastName, and even if it seems that you are calling a property, you are calling the getter. So nothing will change, but the code will be easy to read. We are also going to put all the common configuration in one place to be able to easily modify everything and have everything configured in the same place. And we are going to use these data fixtures to put data that we will use on tests. So instead of creating new objects and doing new user, new organization, new role, new whatever in all the tests, you will put that common code in some things that we call data fixtures. They are also Groovy traits. So let's go. The first thing you need to do is that you don't need to use Groovy for your production code if you want to use Groovy for your test, right? This is a really common approach, using Java for production and Groovy for your tests with Spock. And in those 2 projects I mentioned before, we did that. We wrote the code with Java 8 and Java 11 in those projects, and then we used Groovy for the tests. And we also follow the same approach, for example, for Micronaut itself. Everything in Micronaut is written in Java, but for the tests, we use Spock. And this is what you need to do with the CLI if you want to start a new Micronaut application written in Java using Spock for test. You need to pass the --test feature. This is for Micronaut 2. For Micronaut 1.x, you need to, instead of --test, you need to use --feature. And yeah, so our approach is based in 2 main classes. This application context specification that will extend from the Spock class. And what we are going to do is, if we want to write a test that needs the application context up and running, we will extend from this class. And in this class, what we do basically is we create a new application context and we run it with some configuration. That this configuration is defined in this common configuration fixer. This is the one I talked about, one place to put all the configuration. So in this configuration fixer, you can see here the keyword trait. You apply that in your class, implemented that trait. And then we have this method, get configuration. Remember, in the previous slide, it was configuration, and I said that in Ruby you can call a getter like it was a property. So it's the same. And here, what you need to return is basically a map. This is the configuration key. This is the value. And by default, we create an empty map, and we return it. And we can also put here a lot of things. So for example, if this property is defined, we will set this property with this value. Sorry. And this spec name, again, it's a method called, it's called get spec name, but by default it's null, so we won't create this. I will explain how this works in the future, in the next slides. And also we have this other parent abstract class, embedded server specification. It's the same as before. We extend from SPOC1, implement the configuration trait, and we are going to extend from this class if we want to write an end-to-end test. So if we need an embedded server up and running, we will need to extend from this class. And in this class, what we do is we start an embedded server, again, with the same configuration as before. We also provide an application context, the application context related to that embedded server. This is a method call, so this in Java will be get application context. We also create the HTTP client, again, like we did before, pointing to the URL in which the embedded server is running. And we also define this method, get client, that will return the blocking version of the client. So in any test that we create extending from this class, we will be able to do client dot whatever, right? Instead of HTTP client dot to blocking in every single place. And this is an example of creating a class that extends from this application context specification. So we are going to write an integration test. What we do, we don't have here the @inject. So what we do basically is get the bean directly from the application context. And when we have it, this subject annotation is from SPOC. It doesn't modify the test. It is just for documentation, and it says, this is the subject under test. So it's just for you, for your colleagues, and for the future you to basically document the test. And then you here in the given block, you create something, in this case, save sensor for this shipment. And this method is in this sensor fixer. So this is the place I told you before, in which you put a lot of methods to create all the objects you need for the test. With this approach, you don't have here a very verbose test, right? You only have one line to create the object you need. And also you can have everything in one place. So if you need to modify that in the future, you will do that in one place, and you will fix everything for all your tests. And then here, as you have an integration test, you call the method, whatever you are testing on that bean that you retrieve from the application context. And that's all. You check whatever you think, whatever you want. So this is an integration test, again, because we are extending from this class. For the embedded server, it's pretty much the same. We are going to extend from this. So this means that we will have an embedded server, and we are going to send an HTTP request. Right? So we create a new HTTP request, in this case, to get all the organizations. And then here, using this client, this is, remember, the blocking version of the HTTP client. We send a request, and then we get the response. There are two main methods on the HTTP client. One is exchange, and the other one is retrieve. You will use exchange if you want to check something about the HTTP response. So as I'm using exchange, this method returns an HTTP response. So I can check, for example, here that the response is 200. If you don't care about the HTTP response and only want the body of the response, instead of calling exchange method, you will call retrieve. And that will return directly the body, which is the thing I'm extracting here from the response. So depending on your use case, you probably want to use one or the other. We pretty much always use exchange because it allows us to also check the status, the HTTP status on the response. So what about now about data layer, right? Because we write applications and most of the time we need to persist data on a database or in other place. So with the previous approach I showed you, let's now introduce microdata, for example, to save something on the database. You can use JPA, you can use Hibernate, you can use MongoDB or any storage you want. I'm going to show you how to introduce microdata and how to test that with this approach. And we are going also to talk about this test leakage. This is important. This is one of the, for me, it's one of the worst things that can happen when you write tests, is having this leakage of data. This means that when you run all your tests, a test or more fail. But when you run only that specific test that failed before, it passes, right? This is called test pollution. It means that some test on your test suite put some data in some place that basically make another test fail. This is sometimes really complicated to track down and to fix. So what we are going to do is adding a mechanism to detect that. So a test will fail if we don't clean up all the data it puts on the database. So if that happens, we can detect it and in that specific moment and fix it. So what the approach we are going to follow is create a new trait, repository is fixter, and here we define our application context. Remember, this comes from the main application context specification class. It's the same. Remember these dual thing or names with Groovy getters. You can have the get application context method, and it will reference to the application context property. So this one is that one on the application context specification, and then you define here beans or methods that return beans for all your repositories. So in this example, I have here this sensor repository, and I have I just get the bean, the sensor repository from the application context. And now, once I've done that, I create a new trait that extends from the previous one. And here we define this has leakage method. And in this method, what we are going to check is if there is any data left on the database that hasn't been cleaned up during the test. If so, the test will return true, which means you left some data on the database, right? And then the test should fail. So here, what we do, basically, we can put some print lines or log or whatever, but basically what we do is calling the sensor repository we defined in this trait in the previous slide, and call the count method and check if there is more than one or if there is any data on the database. Here you will add the same pattern for all the repositories you have on the database. And if any of those count methods returns something that is not zero, something, so one or any other row, this method will return true. And remember again, this sensor repository is the one defined before with get sensor repository parentheses as method name. We are using this approach everywhere. With Java, you will use here the get sensor repository method, and it's fine, but it feels more readable if you use this. So how do you apply this leakage detector to your classes? You have your application context specification, and again, you implement that trait. And remember, you can implement more than one trait in the class you need. It's like, as I said, pluggable behavior. And you will override this cleanup method. This method is an Spock method, and Spock will call this cleanup method after every test is executed. So if this method has leakage, returns true, then this assertion will fail during the cleanup phase, and you will know in that specific moment when you run that test that you left some data on the database and you need to clean up. And the same applies for the embedded server specification. Remember, we have these two main parent abstract classes for our test. So we do the same approach. Implement the leakage detector and override the cleanup method, the Spock cleanup method. So how does it look like when there is a test leakage? It's like this, right? I'm running this from IntelliJ. So you have this save as sensor data failure, and on the output, you can see this. This is the Spock output, and you can see that has leakage, return true, so the assertion is false, and the test failed. So if this happened when you are writing this test, you know that you left some data on the database and you need to clean up to avoid this test pollution when you run your whole suite. And you can apply this leakage detector thing not only to database. The idea is to check whatever you want, any resource that you use during your test, and you want to check that it's cleaned up properly. So it's not only for databases, you can put anything there, anything you want. And the idea of doing this, overriding the Spock cleanup method with JUnit, you will use this before, after all, or after test, or whatever is called that annotation. It's to do it automatically. So you don't need to do something specifically to check that you are cleaning up the data. You will write your test, and if you forget to clean up the data, this infrastructure, this leakage detector will let you know, and you can fix it in that specific moment. So speaking about databases, let's talk a little bit more. So by default, we've been using for ages in JVM frameworks H2. H2 for testing, H2 is an in-memory database. So it's helpful because you don't need to install any database. When you start your environment test, the test will bootstrap this database in memory, and you can use that for your tests. And then when you finish your test, everything is gone. So it was a good approach. But how many of you use H2 for production? Maybe if you are writing some kind of small application, or for some use cases, maybe you can use H2. But in real world applications, you use some kind of a real world database, right? You can use Postgres, MySQL, Oracle, whatever you want, right? And what you need to do, it's basically use the same database for production and for your tests, because the behavior is not the same. Some code that works with H2 may fail with Postgres or with MySQL. This happened to me a long time ago, writing a Rails application. We used Postgres for production, but H2 for our integration test. And one day, someone reported an issue, and the first thing we thought was, we have an integration test for that. It shouldn't fail. So we checked the test, and it worked. But then we run the application, and it failed. So what we did was switch the database used for tests from H2 to Postgres. And I remember that something like 40 or 50 tests fail because the behavior of the database is not the same. So from that moment, 7 years ago, I always use the same database for production and for tests. And some time ago, it was more complicated. But even nowadays, I hear excuses for people that are still using H2 for their tests, like, yeah, but if I use Postgres for my test, then I need to, set up the DB locally. And yeah, I run Linux, and for me, it's just a matter of it's pretty simple to install. But yeah, I run Windows, and it's a nightmare to install my database, or yeah, and if I do that, I also need to install that database in my G environment, right? Because if not, the test won't be able to run. And I need to excuses everywhere. So please stop making excuses for not testing properly. You need to use the right tools. And yes, and you may imagine the right tool for this, for testing the real database, is using test containers. I don't know if you know. Test containers basically allows us to use Docker containers for our dependencies during integration test. So this way we can run real integration and functional tests against a real dependency. It can be a database, it can be a RabbitMQ, a Kafka, Redis, anything that you can put inside a Docker container, you can use it for your integration tests. And this is a really well-maintained library. The development team is doing a really, really, really great job maintaining, evolving, and implementing new features in the library. And it's basically becoming the de facto tool for this kind of test. We use this in Micronaut in different modules for testing, for example, RabbitMQ, for testing Kafka, for different databases. And a lot of JVM projects have moved to use test containers for their tests because it works really, really good. If you want to start using, or if you want to add test containers to this project and this setup I'm talking about, the only thing we did when we added that was the dependencies. So basically test containers, in this case for Spock and for MySQL, that was the database we were using in this project. Or if you are using JUnit, the same dependency for test containers and for the MySQL again, and JUnit Jupyter. And what you need to do is annotate your classes with a test containers. So it knows that the test container dependency knows that you want to start a Docker container. The problem is that I don't want to modify all my tests and put test containers everywhere, right? So what we did in this project, it's creating a couple of classes, and I'm going to show you how we wire up everything, because it's really simple. We created this class, MySQL. We have this static MySQL container. This class, MySQL container, came from test containers. And what we do in this static method basically is if the container is null, we create a new MySQL container, we set database username and password, and start the container. And that's all. And you don't even need to care, or you don't even need to worry about the username, the password, and the database. It doesn't matter. You can put there anything you want. And then we create another trait, MySQL container fixer. We define a method, get MySQL configuration. Take a look because it returns also a map. So we are returning some kind of configuration key values. And what we do in this method is basically, if the MySQL container is null or it's not running, we call the init method. I showed you in the previous slide that we will trigger the creation of the MySQL container for the test. And then we return a map. This is a map in Groovy. So yeah, in Groovy. So you have key, column, value, right? So we define these three properties: data sources, your default URL, password, and username, which Micronaut needs to connect to the database. And as you see here, we don't even care about the username, the password, and the URL. We just call the container and say, please give me the URL, the password, and the username. So with just that, you are able to start the Docker container and configure Micronaut properly to use that MySQL instance for your test. So now the only thing you need to do is wire up here everything in this configuration fixer. This is how it looks like before. So what we are going to do now is implementing the trait and adding the configuration to this map. For those of you who are not familiar with Groovy, here what we are doing, so M is a map. This is by default a hash map. And remember, this is coming from this fixer. It's called get MySQL configuration, parentheses, parentheses. It's a method that returns a map. So with this plus equals, we are basically adding all the map in this one. In Java, you will do something like m.put all or put values or whatever it's called. It's the same, right? It's just with Groovy it's easier because it's this operator is overloaded, so it's easy to read. So basically, this will trigger the creation of the Docker container if it's not running, and it adds the configuration to this map with the configuration that we use in our application context specification or in our embedded server specification. And we don't need to annotate any class. With these two classes and this configuration here, now we have Docker up and running for our tests. With MySQL in this case. So it's pretty cool and pretty simple to use test containers. And that's all you need to do. Okay, what else? We also want to mock collaborators sometimes, right? Because we need to test different things. So my recommendation is always use interfaces. Even if you know that you will only have one implementation, it's better to create an interface for that and inject that interface in all your production code. And you do that because with Micronaut, it's pretty simple to have another implementation of that interface and use that for your test when you need it. So to do that, you create a new class that implements that interface, and you annotate that class in your test with a singleton to make it Micronaut bin, and with a primary. Primary is a Micronaut annotation. And this annotation, what it does is that when you have more than one bin of one type, right, the primary wins. So this means that you will have two bins of this, user service, one on your production code, one on your test code, and you will annotate the one on your test code with a primary. So Micronaut will inject that on your production code. But to avoid injecting that bin in all the tests, you also annotate that with @requires property. This @requires annotation, it's really powerful, and you can define a lot of different combinations of property values, bins, a lot of things. So basically, the thing that you put here needs to be true to be able or to tell Micronaut that the bin will be created. So in this case, what we use this spec name, and if the value is something, then Micronaut will create a bin. So how do we use this in an example to mock some dependency? So this is what we have. We are extending from this embedded server specification again. So this means we are going to write an end-to-end test. And this is what I want to test. I want to send a post request to this endpoint, and yeah, I check whatever, right? And I know that this controller calls a service, but I don't want to worry about that service in my test because whatever reasons. In this case, it was because this service was calling a third-party blockchain API, and I didn't want to test that part in this test. I did that in other tests, but for this specific test I'm showing you here, I didn't want to deal with that. So what I did was creating in my same class, in my same test class, I created a new class that implemented the same interface I use for my production code. And in this case, as I didn't worry about that and it returns void, I don't do anything, right? If this returns something, I should return here correct value. And then I annotate with a singleton to make it a Micronaut bin. I annotate it with a primary, and I say, okay, Micronaut, you will be able to create this bin if this property has this value. So where do we define this value? Here. Remember this get spec name that was defined in the configuration fixer? Here we override it, and then we set it. So basically what we are saying, and here you can use any value you want. We use always the name of the test because it's simpler. You copy and paste the name and you don't need to think too much. So with this, what happens is that as we are overriding this, when we start the embedded server, this property, this value will be used in the spec name configuration. And then Micronaut will see this value here and will be able to create this mock bin. We use this spec.name requires approach a lot in Micronaut itself to test different parts of the framework for security or for all different stuff. So it's really, really powerful, and you can do a lot of things with this requires. So this is what I said before. As we are defining the get spec name, because now it's not null, we put the value here. So what we are doing is defining in this map the spec.name value with this, the spec.name property with this value, Hanover controller star Hanover spec, right? So this is how everything is wired up. And other times, instead of mocking one part, you may want to write some kind of global mock for all your code. Think about, for example, security. Maybe you don't want to deal with security in every single test you write. You may want to disable some kind of security and only enable that security in some specific tests in which you actually test that. So to do that, what you need to do is create a new bin, and you need to configure that bin to be able to enable and disable that bin per test. So this is an example I use. I have this shipment security service, and I create a new class, mock shipment security service. And in this case, I override the methods in the interface saying that can user access to shipment, and I always return true, right? Because I don't want to test that in all my tests, but I make this conditional again. So Micronaut will create this bin only for the test environment, just to make sure we never execute this fake security on production, and only when this property mock shipment security service is true. So basically you need to explicitly enable the bin, this mock bin. And how do you do that? In our configuration fixer again, we define a new property, mock shipment security service, but instead of putting here just true, we call a method, and in this method we return true by default. Why do we call a method? Because of this. If we define a method in this class, we can override this method in any test. And this is, for example, from IntelliJ. if you override this method in any test and click this here on this icon on the cutter, you will see all the tests in which we have this defined. And in all those tests, instead of putting here a true, we put a false. So this mock bean service won't be created. And in those tests, you will test the actual security. But for the rest of the test, you have a sensible default, which is, okay, I don't want to worry about security. And what about third-party APIs? How do we mock third-party APIs? Because we don't want to call in our test, we don't want to do pretty much, I don't know if never, but sometimes we don't want to call third parties, right? Doing an external HTTP request. So what we do is that you can start another embedded server and mock that third party in another embedded server, or even more than one. And that new embedded server will start its own application context. It will have its own beans. And what you will do is create controllers with the response needed, and that will mimic the API you want to mock. So let's see with an example. In this class, embedded server specification, you define a port. This class is from Micronaut and basically finds a new TCP port that is available to start the new embedded server. And then you create a new class. This is because it was for blockchain. So you extend from this one. And in this one, you start a new embedded server with the same configuration we've been using before, but we modify the port to start on another port. And we define this to the spec name because we want to mock that. And in our configuration fixture, what we do basically is put a new condition. If that property is defined, we set this. This is the configuration key we use in this project to define the EOS blockchain API, and it points to localhost and this new port. This is the port for the new embedded server we are going to use for mocking this third-party API. So how do we use this? We extend from the new class, and then we get the bean, we call it, we check something. So nothing changed here. This is pretty much the same test we wrote before. But then in the same test, in the same class, what we do is create a new class. And in this class, we mimic the API. So in this case, this is the endpoint that this blockchain API has, v1 chain get table rows. So we mimic that. We return whatever we want to make sure that it works. We can throw an exception. We can return a 500, whatever, to make sure that we test all the different cases. This is for the happy path. And we also make this bean again conditional. So it will only be enabled when this spec name value is like this. And again, as I showed you before, we define this, the value here to enable that. So is this fast? You may wonder how much time does it take to run the tests in this project after everything I explained. Starting new application context for running integration tests, starting embedded servers for the functional test, starting the Docker container, using a real database. So this is a screenshot of a short video I'm going to show you. And you need to take a look at two places here. Here, every time you see here a new line appearing, a new number, it means that a new embedded server has been started on some random port. And the other thing you need to do here, it's the clock. So when I recorded this video a couple of weeks ago, so you will see that it's real time. I'm not cheating. I'm not playing the video 2, 3, 5 times faster, right? So try to, now when I play the video, try to take a look at this here and try to count how many embedded servers this test start. So let's play the video. It's only like less than 1 minute. So it's running, and you can see now the embedded servers are being started and stopped. And if you take a look at the clock on the upper right side of the screen, you will be able to see that it's real time. I'm not cheating. So remember, every time you see here a new port appearing, it means that a new embedded server was started for a test and stopped it, right? So it only has something like 10 seconds left. So let's wait. And now let's see if you were able to count all the embedded servers or not. Okay, it finished. So can we answer now the question, is this approach is running or writing pretty much everything as integration test and a unit test, as integration and functional test fast using Micronaut. I ran this project on my old 4 years old laptop, so it's not the latest and fastest laptop on the market. And in this project, there are 519 tests, and it took 1 minute and 30 seconds to run GradeLW clean check. So it's not only running tests, it's cleaning up everything, it's recompiling the source code, the test, doing the check style, everything. And it took less than 2 minutes. And do you know how many unit tests, integration, and end-to-end tests are in this project? 15% of the tests are unit tests, 62 integration tests, and 23% end-to-end, which means that 85% of the tests in this project run application context, start embedded servers, and does everything in less than 2 minutes, right? So I think that this is, I don't know what you think, but I think this is pretty fast, right? Being able to run everything in less than those 2 minutes, it's really, really fast. And if all the tests pass, you will be confident that your application will behave as expected because you written most of your tests as integration and functional tests, right? And this is a solution. We started 85 embedded servers in that 1 minute and 30 seconds. So a lot of embedded servers were started and stopped during our 120 integration tests, functional tests. So does it really matter? I replied a tweet a couple of weeks ago on Twitter talking about that. And someone said that this is actually a better argument about the Micronaut fast startup instead of saying, okay, my Hello World application starts in 500 milliseconds, right? Because it's really, really fast to write tests with a framework like Micronaut. And also Graham replied to that tweet saying, yeah, and it also eliminates the need for us to build complex mocking APIs in Micronaut like those that exist in Spring, since they are completely unnecessary because as everything is so fast, we don't need to write mocks. And that's a benefit for us. We don't need to write that code and maintain it. And that's a real benefit for users because you will run the same code on your tests and you don't need to wait too much to run your tests. So what are the pros of this approach? You have total control about everything. You can mock collaborators, as I explained, creating different beans, conditional. You mock third parties APIs, creating different embedded servers. It's pretty simple to add new dependencies. You saw how easy it is to start using a real database with test containers. I also added in this project some months ago MQTT support, and I also use test containers with an MQTT broker to make sure that our integration tests work properly. Everything is easy to read because of Ruby. As I said, you can do this with Java, you can do this with Kotlin. With Kotlin, it probably will be pretty as in Ruby. With Java, it's not that pretty, but you can do it pretty much the same. And after using this approach in 2 projects, it works really, really well. And I think we will use this for more projects in the future for sure. On the con side, this initial configuration, right? It's not that simple to set up everything, but now you have the slides and I said I will put some code on GitHub. So you will have an example of this working. And you cannot use at inject. So you need to do application context.getBean. So it's just a small cons on this side. So basically the conclusions is that I show you different approaches to testing Micronaut applications. I show you one in detail that we've been using for a long time in different projects. Running Micronaut integration and functional tests, it's really, really fast. And it's a really nice developer experience. You don't need to wait too much for everything to start up. And the application, as the project evolves and you have new requirements, it's easy to integrate everything with tests and add new features. Of course, Spock from the win. As I said, for me, it's the best testing framework on the JVM. And we also take advantage here of some Groovy nice features as traits and these getters. So finally, do whatever you want. Do TDD, don't do TDD. Start testing first your repositories, your controllers, your services, but please do write tests. It's really, really important to write tests. Thank you very much.
If you have any other questions and you want to go ahead and put those in the Q&A, we can stick around for a few more minutes and answer any of those questions. Someone asked if the example source code is available on GitHub for this.
I don't have the source code available. You will have the slides with pretty much everything, but I can put an example, skeleton of what I've talked in a few days on GitHub. So yeah, it will be available.
Thanks, Iván. We appreciate you joining us, and we'll see you on our next webinar. Thank you.